kind of repeating back to this blood alcohol level. So how do I test the blood itself for alcohol content? And again, this is generally going to be done in a hospital setting. So gas chromatography is the standard. We are going to use so we talked about gas chromatography in the drugs unit, where we take a sample of the blood and then it's put into a chamber, and as it's heated up, it's processed, and as the higher boiling points come out first, or the lower boiling points come out first, the higher boiling points come out later. And so based off of the retention time, they know when alcohol comes out. And so they can do an analytical method through gas chromatography. And that's probably the typical. But a lot of them also use enzymatic oxidation. So in a hospital setting, when they're trying to do it, they often do. So what they do in this case is they're actually chemically reacting it and detecting the products. So this one is they use the serum alcohol level. So you don't actually test the blood, you test the blood serum. Now, I don't need you to know necessarily this, but the idea is that blood has red blood cells and white blood cells and platelets, and then plasma, which includes clotting factors and serum. So they separate out just the serum, and they're testing just the serum. And so there has to be a conversion factor to say, yes, but since we're testing the serum, the value will be different than it is in the blood. And that factor is like 1.16, but it can vary under different circumstances. So they do a conversion, but again, this is something, every time you do an extra step, it's a part where it's going to be contested, especially in an area where, we have many, many lawyers acting as defense lawyers and actively pursuing this. So to be aware of that. So how do you collect and preserve the blood, right? So I want to take the blood and then I want to go send it to the lab to be able to do either gas chromatography or an oxidative analysis on it. So you have to draw it under medically acceptable conditions. So it's going to have to be clean, sterile procedure by somebody who actually knows how to collect the blood properly. Right? A lot of times when we're doing blood work, they use that little alcohol swab and then they kind of swab it on, to disinfect. Can't be an alcoholic disinfectant, or else you're going to change your values. You're going to add in alcohol to the sample. It needs to be preserved in an airtight container. We don't want, the air will continue to react with the blood if we have it in air. So it's going to be an airtight container, and you have to add some preservative and anticoagulant to it to make sure the blood doesn't thicken up and it stays the same. If you do that and you store it in a refrigerator, the blood alcohol content should stay fixed by the time it gets to the lab. If you don't do that, it can degrade so that by the time the sample is processed, the blood alcohol content has changed. If you don't properly preserve it, that's what we're saying, is that you may have a lowering so that by the time it's tested, they were at 0.11 blood alcohol. By the time it's tested, it's at 0.07. Also,
what kind of disinfectant can you use that's not alcoholic?
I think that they use the betadine. But I'm not actually sure. That's a great question. So I don't have my phlebotomy license to be able to do this. So, there are people who do this, and I could try to find out. But they would, there's plenty of disinfectants. So I'm sure they use a different one. Probably betadine is the brown one that stains your skin.
Oh, okay.
So I'm guessing that it may be in a base of some alcohol. Alcohol is a great solvent. Good question. I'm going to find out. I'll find out from you. I know somebody who works in the coroner's department, and I think they know she may do some of the blood draws.
Cool.
And so again, as the bodies decompose, a dead body, that decomposition of the body, which starts happening immediately upon death, can actually produce alcohol and change the results. So that's something to be aware of. Okay, so we basically have these charts to then predict blood alcohol content based off of drinking conditions, right? We sort of talked about this before. These are pretty helpful. So there are many, many factors, and it's actually a little bit more complicated than this. Guess what your project for the toxicology unit is going to be? It's going to be doing one of these, but I'm going to have you do it mathematically. I'll give you all the instructions and step you through it. And there's many calculators, but I'm going to have you do it on the project. I'm going to step you through actually doing all these conversions. So it's based off of how much food you've eaten, your body weight, how much you've drank, and how much time has gone by. So on this next page, I have now I got this is the one from this Brad 21 organization, and they have one for men and one for women, but rather than making 2 slides, I just made one for the men's. So this is for men because, of course, and the difference is that women have a different water content percentage in their body than men. So it's not only body weight, but also how much of your body. So women have a higher fat percentage than men do, and all the alcohol is concentrated in the water area. So women actually have higher blood alcohol contents for the same amount because it's concentrated into less volume of the water areas. All right, so in this case, I have my pounds on the top, and down here is how many drinks they've had. And on the bottom, it says a drink is a 1.25 ounce. That's like a shot of 80 proof liquor. Again, if you change which proof it is, that changes. 12 ounces of beer. And again, for the most part, beer is around 5% alcohol, but it can vary. And 5 ounces of table wine. Table wine's about 14% alcohol. But again, they can vary. Some of them are a little bit stronger, some are a little weaker. So based off of those being drinks, it also says on the bottom to subtract 0.01 for every 40 minutes of drinking. So that as time goes by, remember, your body, as soon as you consume it, it absorbs it. And as soon as it's absorbed, it begins to eliminate it through that oxidation process. So it's burning some of it up and converting it into acetic acid and then CO2 and water as you're sitting. So with that, you can expect it's going to decline over time. And so that's what this 40 minutes of drinking is every 40 minutes, assume that you get through. And remember, our burn off rate was 0.015. So this is where this is coming from. It's using a 0.01 to make it a little easier. So we see it also has, this is nice where it's really kind of telling me the zone is that up until 0.08, 0.08 is legally intoxicated, but this blue area slightly below still can have effects on your driving skills and still can have some criminal penalties. Even though it's not legally intoxicated, it's still going to have an issue. So let's try and do these. Your friend is a 185-pound male and was tailgating before the football game. He ate a meal, so 185 pounds. He had a meal and had 5 beers over 2 hours, which is 120 minutes. What is his BAC likely to be at the end of those 2 hours? So let's go back and work this through together. All right, if I have 185 pounds, so I'm going to use 180 pounds because it's close, but it's kind of in between here and here. And 5 beers, so that would be 0.11 over 2 hours, which is 120 minutes. So 120 minutes is divided by 40 is 3. So I'm going to subtract 0.01 3 times. So minus 0.01, minus 0.01, minus 0.01, or minus 0.03, I don't care. We get to 0.08, right? Are we good there? Do I need to write it down or you guys got it? All right, whoops, back up. So the second one says, your friend is a 150-pound male and was at a party and was challenged to take 10 shots of vodka over the course of 30 minutes. 10 shots, 30 minutes, and a 150-pound male. So as I look here, 150 pounds is going to be between 140 and 160, so halfway between. And as I go down, 10 is 0.27. Now, it was over 30 minutes, but I haven't even burned any off. I need at least 40 minutes to get that burn off rate. So it should be about 0.27. Note that this is in that range. We were talking the other day about what is the range, and I was saying I think it's like 0.4, 0.5. So they're saying as low as 0.3, 0.27, you can be, you can die from alcohol poisoning as at 0.27. Now, obviously, different bodies, different tolerances, different things doesn't mean it's automatic. But when you're in this above 0.3 And I think we were talking about the hazing incident at LSU, and it was in, I think it was 0.4. Does anyone remember what it was? Who was that? Zach who was telling us about it? Or was that Hunter? Anyways, whatever it was, he went into a coma, but it was, I remember we were discussing 0.4. Yeah. So we're talking about here in this corner where, you know, he may or may not die, but it's super serious. And that's something to really be concerned about with drinking shots, is that because it only takes a couple seconds to drink the shot, you can drink them in quick succession to the point where, especially if you're not a particularly big person, it doesn't take much to get into this zone where you're in coma.